Hello, everyone. Thank you for having us here, the Dissecting team. This is, I think, the third or maybe fourth conference that we are presenting this research. And let me talk a little bit about the research before we dive in. Dissecting non-malicious artifacts, basically taking samples which are non-malicious and trying to extract not internet protocol, but intellectual property. So that was part of what we found, and we're going to extend about it. Jump in. So just about us in like two sentences. So you're clicking. How do I do it?
Yeah.
Like, do I need to? Like,
you can tap the floor.
We're the founders of Virus Bay. Who knows what Virus Bay is? More hands, please. Malware researchers. So basically, it's a social network for malware researchers to exchange samples. After a few problems that we found, we decided that it would be good to found this tiny project, which grew up to be around 2,000 researchers worldwide exchanging stuff. So if you're doing anything around malware, you probably should be there. I'm working for Kaspersky at a team called the GREAT, Global Research and Analysis Team. Just Google it. And Dani is from Andot, which is his own company. I'm basically an alumni and a lecturer for a college in Israel called the College of Management. Dani is a student for Berkeley. I'm a father of 3, and Dani is active on Tinder. So we're both from Israel, and you need to click so they can see the flag. Yeah, Israel. That's my first time in Sweden. That's your first?
Yeah.
First time in Sweden.
Loving
Great
it.
country. Yeah, we love it. Love the people. And we don't say it on every country. So, okay, let's go. So, disclaimer before we go. We had much more content in this research, and a few companies called XYZ, they were very friendly to call us and say, don't do that. So many of the content we have here was redacted. You can approach us later. Maybe we will give you some hints, but we pretty much removed a lot of the data. We tried to make it make sense. So let's go and see how we can do it. So basically, the research motive, once you dive into research malware, some of the malware will be in the attack vector, some of it will be in the lateral movement, some of it will be in the data exfiltration. There's specific phases of malware or hacker behavior where you can find interesting artifacts. This example was from the attack vector. And once we were looking for attack vectors over email, like phishing emails, spear phishing emails, this is one of the examples that we found, and this is not a malicious sample. And it was found in a place where a lot of malicious samples reside. So it was a very interesting find, and we wanted to make sure if it's something specific or maybe it's a global problem, and we can find more artifacts. As you can see, we found some interesting headers that gave it away that we might dealing with something that is bigger than us, maybe something that leaks these artifacts online to either paid or non-paid services. Of course, we had to redact the headers. So the research concept is basically around the regular pillars, employees, which they suck. We always leak data from our corporate and constantly making mistakes. Anyone heard about the Amazon incident? Slight incident. $500 million burned. Nobody heard about it? Oh, come on, people. Seriously? There was some employee of Amazon who decided it would be cool to just torch one of their warehouses. No, seriously? You haven't heard about it? Crap. People, you don't read the news. Like, all the news are crap, but some news are true. Like, you should read them. So insider problem or insider issues, yeah, that's for real. So security products are not supposed to leak data, something that we thought, and that's why we emphasize it. Of course, vendors, we have a lot of vendors, whether it's security vendors for companies or other vendors, which basically does what they do, and then they take your data and who knows where it's going, and hackers. We're going to focus on one of these pillars, which is obvious, security products. And the focus of security products is because we wanted to make sure that what we saw over there was not a coincidence. And I mean, one of the main, stop clicking, wait, let me talk.
Okay.
Come on, I invested so much time in
last
the
time
animation.
last time I wasn't clicking, so now I'm clicking too fast.
Okay,
we're learning.
He wants to leave time for his demo. I got you, okay. So basically, in that specific case, which we showed just earlier, it was an email that had no detection. So that got us thinking that maybe if we focus on those who has zero detection, we might find either unknown APTs, some interesting samples, which we all like as malware researchers, but also we can find garbage. However, one person's garbage is this time for animation. One person's garbage is another person's gold. So we wanted to find within that garbage maybe a proof to what we saw initially. For the research goals, we had some starting points and building blocks. One of the first ones were searching online, whether it's paid or unpaid. The other one was code repositories. Maybe we could find some more artifacts other than samples. I mean, like passwords or certificates or stuff like that, which are being leaked in some other way. And some other repositories or other places where I will list them down just in a couple of slides. The building blocks were malware research, places where you find, places where you originally find samples and basically want to find something else. Then, if you take all the collection, then you need to somehow filter it. Anyone is familiar with Yara rules? Great, amazing, you're awake. So Yara, for those of you who don't know, is a coding language which filters binaries. So it's very, very much in use, especially around malware researchers. I will show a couple examples, very simple ones for those of you who don't know what Yara is. And I really recommend you to go ahead and check what it is. And of course, Dani's black magic, which he calls data science, and I have no idea about. And he's going to talk a little bit more about that that side of the research. And taking these two, the starting points and the building blocks, we want to create the goal. And the goal was to actually prove that data is being unwillingly exfiltrated from organizations around the entire world to some specific places. Proof of concept, I don't know, I'll keep with the hands to keep you awake. Anyone knows hybrid analysis? Sandbox online. Okay, that's an example. We were talking with of course, please, when you post stuff like that, get approval. Okay, we got an approval for that specific file. We found it very quickly. And as you can see, it's very blurred, but we kind of magnified it for you. And it's very personal, very confidential document, which was created somewhere in mid-2018, so it's fairly new. And by searching over hybrid analysis for the word message, you can actually find these type of stuff. Easily, you can find them. And the question is, how did it get there? So 3 options, which I found. Maybe you can think of more options, but I'm more interested in the middle one. Was it a security product that might be using something to boost their detection and send this interesting intellectual property online without no one knowing about it? And who are these projects? Who implemented these products or who deployed them? And what is the module that actually creates this type of behavior? And this is just an example for the intellectual property. Like, imagine you can find thousands of them. Let's go. So during our research, we found a lot of stuff. We reducted the examples, so we're just going to show these icons. So as you can see, you can find a lot of stuff like code, dumps, documents, certificates. Sometimes you can find like database dumps, completely database dumps, which are being sent from one end to another, explaining about everything that is included within these dumps. And et cetera, et cetera, et cetera. You can find a lot of interesting stuff. The possible feeds where you can actually find these is in code repositories, open source, some paste repositories, which we all know and love, malware repositories, multi-scanners. What else do you have there? Online sandboxes, which I just talked about, and social platforms as well. Believe it or not, you can find them also in IM, like instant messaging apps, if you're in the right group. So you can be like silent in some group, and then someone is conducting something, and then you find this information being transferred inside these groups. About Yara rules. So this is a very simple Yara rule for EMLs. EMLs are email files, which you can find basically anywhere. And going down, no, go back one. So just about like quick talking about the structure of the Yara rule. So basically you have the name of the rule, and then curly brackets, and you have to have the strings, and beneath it the condition. Over here you can see that we are looking for the from and to and the subject in EML 123, the attachment, which is one of the headers, and the MIME type. And in the condition, very easy, all of the EML with the wildcard, so all the variables, and the attachment, and the MIME type, and larger than 300 kilobytes. Anyone has a guess why larger than 300 kilobytes? Raise your hands. No. Cooperate. No? OK. You. What's your name? No, I know your name. Do you know why, Gabriel? Yeah, if it has an attachment, and one more thing, if it maybe has a thread. So maybe if it has a thread, we saw some phishing emails with threads, but some of them with threads might have some juicy info in them, and not like only slight stuff. So this is why we added, and just as Gabriel said, if they have an attachment. The other one is just similar. You can click now. The only thing that has a difference is the bytes. So an Outlook file is different. So you have to use on the first variable, you have to use the curly brackets in order to have the first bytes of the file. So of course, you know, for samples like executables, it's the MZ, and for Outlook, it has their own. About the collection. So once we wanted to create a collection from all of that, the ways on how to do the collection is basically very simple. Once we actually understood which feeds we want to take as subjects, we found which samples we were interested in. We created a list of hashes from the feed, from the JSON feed, like a list of hashes, downloaded based on the hashes, and filtered the samples with Yara rules so we can find the interesting ones, and we sent them to a pipeline, which Dani will explain about. Yeah.
All right, let's switch.
Cool.
So we wanted to build a big pipeline to collect everything automatically every day. So we started from data feeds. We just took a collection of a couple of data feeds that we want to collect, and we made an automated process to collect it twice a day. Yeah, you can click through.
Oh, OK.
All right, so we had a Lambda function, which would collect everything, send every file into a queue, and we would have a whole process gathering the data, cleaning the emails. We'll show the analysis pipeline in a later slide. We would save it all, and then we would have a nice dashboard to see everything, to extract all the juicy information out, and basically have a proof of concept of how we can automatically collect data from Fortune 1,000 companies with a couple lines of code.
Want me to go all the way?
Yeah.
I like it when
So
you
we,
say it.
so we started with an email queue. We would get emails. First thing we would do, since we were working on emails that were marked as spam, we would try to filter them. We made a very basic classifier with our number 1 feature, which is Viagra, which filtered 80% of the emails out. We used a couple of custom parsers like Apache Tika, which basically can take almost any type of file and extract the text out and the metadata. After that, we would go into, we have like this big, this side, this big pipeline. So we would start with cleaning out data, removing stop words. We were using a few popular NLP techniques. So we did named entity recognition, which we'll show you in the demo. We did topic modeling, which would basically take all the emails, and from each email, we extract the main words that it thinks that would be the topic. We used two ways to do it. We used NMF and LDA. After that, we had our own composite score for each email of how critical it is, how sensitive the information is. We would feed it into Elasticsearch, and we had a visualization via Kibana. So we did a nice graph-based approach. We just wanted to see how the emails were interacting. And you can see this is a subsample of about 1,000 emails. And you can see that there's 4 big clusters, which were 4 big companies, which were interacting with each other. And all of the data was leaked. And as you can see from the amount of connections they have, this is 4 Fortune 500 companies leaking data. This is a worldwide problem. It goes from every country. We found 150 countries in our data set, which means it's a global problem. So there's nothing local that's causing the leaks.
Your demo.
All right, let's go to the demo. OK, so the first thing we started with was a header analysis. We redacted all the header data, so unfortunately, this is all we can show you about the headers, a bunch of 1s and 0s. So this is a subset of emails. I'm showing you only the first 15, and a 1 means that it had a specific header in, and 0 means that it didn't. So each row is basically all the headers that we're looking for. So if we start with doing a little bit of clustering. We just wanted to see if it's like a widespread, like different products, or just random stuff, or are there any meaningful clusters of specific groups of headers that were leaking the data. And as you can see here, we did find, so each color is basically, we used the cosine similarity to cluster all the headers, and you can see that we have 4 clusters right there from different colors. So this made us believe that there's specific products that were leaking the data because there is a lot of similarity between all of the emails. We clustered them pretty easily. Next thing we did is we wanted to find, OK, we have a lot of emails. Let's try to categorize them into a couple of groups and see if there's anything meaningful, if we have categories of specific types of emails leaking. So we used both LDA, which is latent direct allocation, and NMF, both statistical ways to try to find similarities and find, it's called topic modeling. So you're basically extracting topics from all of your emails or all of your texts, and you're trying to categorize each one. So I'm going to show you NMF since LDA is takes a little bit long time. And there you can see that we found 10 topics, which is 10 words that categorize our documents. So there's order, invoice. This is one category. We had quotes and also orders, different reports, We found a lot of financial documents, a lot of trading-related stuff, a lot of bank statements. Also, a lot of HR. We found a lot of emails with employee resumes, passports, everything that should not be leaked anywhere. And then the last thing we did is named entity recognition. So we used a pre-trained model to extract named entities like companies, dates, currencies, different people, their roles in the company. So since we had to redact everything, we couldn't show you live on a real email, so we just made a fake email, but we'll show you how it works. Yeah, there we go. Okay, so you can see the text, me, the text.
For those of you who know politics.
The text, the F-35 fighter jet is a work of art. We can debate that. Israeli Air Force, country like Israel, the price, which is $23 million. I think that was pretty cheap, isn't it?
Yeah.
For a plane, yeah.
It's also
and then there's also a discount for a company called Stealthy Air. Pretty nice discount. So all of this went to our pipeline. So at the end of the day, we have a dashboard of the topics from the email, of the people conversing in that email, companies related, different works of art, and currency. So as an attacker, this would be a pretty useful tool for you to have in your arsenal just every day, getting emails from Fortune 500 companies, knowing a lot of data. It can go from price manipulations in the markets to blackmail.
You want to give the example with the IPO?
Yeah, so one of the emails we found was between a legal firm and a company which is going on an IPO with all the details of their IPO.
A week before the...
A week before the IPO. Yeah. All right, so...
We're looking for sponsors. Actively private investors. I need someone to blame.
Yeah, so this is our presentation.
Go to the questions and all that.
Yeah.
Crap. Oh, wait, we have the virus bay code. Go back to the presentation. So this is where you ask questions. We have a special slide for it. If you have any questions regarding the topic, before we move to the interesting part, which is the invite code, be my guest. Questions? Raising hands? Cooperate? We're here? Nothing. Dead. Can we say one word about the code before we go on? Yeah. Okay. Sure. So basically, VirusBay is a nonprofit, and you have here the website, and you have an invite code. So you just write it down. It says like Secti Sweden 2018. For those of you who don't see, and basically you go on, you register, and you can start play, and we invite you all, regardless of your role. Yeah.
Cool. And since you're a little bit faster than you actually save about 5 minutes of your time, so you can take questions from the audience. I'm sure there are things that people want to know. Do we have microphones?
Stand up. What's your name? Which country are you from?
Nope.
Hi. So how did the disclosure process look like in front of, I guess you had to do it with a lot of companies.
Oh, they did it with us.
Oh.
Hi, Enver from Israel. So this is great work. What I understood from the presentation is the stuff you found. What I'm looking to hear is, did you figure out how it got leaked? And therefore, the disclosure, actually following up on that question, has two faces. The one is the owner of the data that needs to know it leaked, and the other one is the responsible for the leakage.
This is an amazing question.
Thank you.
Because it was part of the redacted area. So basically what Inbar was asking is, did we figure out inside the code of these security solutions whether, so did we figure out where exactly in which line of code does the leakage occur? And we do have a couple of VMs which I don't know if it's the right place and right time, but you know, we can meet in Mossad HQ and we can work together. But basically, yeah, we did it for 2 or 3 of them. Some of them have the information like out there if you find it. Some of them has a background already. If you look in news 2015, 2016, you'll find that they're already been there. Yeah.
Some of them were using like really, really old modules we found like on really old websites. They were using some small agents to scan the files, and we did see that some of these agents do, since they're very, very old, they do not really have a very big signature base, so they rely on third-party services. We did not reverse engineer them, but we did see we rely on third-party services for virus scanning. So it's like a chain of the big part is using some small agent, which is small agent is using third-party services.
Cybersecurity.
More questions? No? What's your data feed?
Our data feed?
Yep.
No comment.
I guess it's a great question, but I mean, this is a question that, you know, it's like a cloud above us, like the data feeds. I mean, as a professional person from the cyber scene, I think focusing on where the data is exfiltrated, where is it now resides, it's not very interesting. It's more interesting which are the security products, which are being, like, I mean, you will solve it by connecting with them instead of blaming Facebook.
All right.
Yeah.
All right. Thank you so much again.